Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Let's balance the following reactions. For A, we're going to do this in basic conditions. MnOH2 solid plus H2O2 aqueous in base would yield MnOH3 solid. Let's break this apart into two half reactions. MnOH2 solid to MnOH3 solid. Manganese is balanced on each side. 2 oxygens on the left, 3 on the right, so H2O on the left. That leaves me with 4 hydrogens on the left. I need 1 hydrogen on the right and 1 electron on the right. H2O2, and to balance this, we'll put 2 H2O to balance the oxygens, and 4 hydrogens, 2H plus to balance the hydrogens, and 2 electrons to balance the charge. I'm going to double this half reaction here. That would allow me to cancel out the electrons, and this would leave me with 2, H2O would also cancel, H plus would also cancel, and I am left with Mn MnOH2 plus H2O2 to 2MnOH3 solid, and there's my balanced reaction. This one is neither acidic nor basic. It's done just in neutral conditions, but in the presence of base. For B, we have MnO4 2 minus in the presence of acid to produce MnO2 solid and MnO4 minus aqueous. Let's break this apart into two separate half reactions. To MnO2 solid, manganese balanced, 2H2O to balance the oxygen, 4H plus to balance the hydrogen, and 2 electrons to balance the charge. MnO4 2 minus to MnO4 minus. We need 1 electron to balance the charge. I'm going to double this here. And I am going to find that the electrons will cancel. And those are the only things that will cancel. So I'm going to be left with MnO4 2 minus, 3 MnO4, we can combine those together, add 4H plus to MnO2 solid and 2 MnO4 minus and 2H2O, and there's my balanced equation. For C, we're going to balance this in acid. We have IO3 minus add I minus in the presence of acid, and this will produce I3 minus. Let's break this up into two half reactions. Let's first put a 3 here to balance the iodine, 9H2O to balance the oxygen, 18H plus to balance the hydrogen. Now let's balance the charge. I have -1 on the right, 18 minus 3. So I'll need 16 electrons to balance the charge. Second half reaction. Put a 3 here to balance the electron, or the iodine, and 2 electrons to balance the charge. I need to multiply the first half reaction by 1, the second half reaction by 8. 16 electrons, 18H plus, 3iO3 minus, I3 minus, 9H2O, and times 8, 24I minus, 8I3, and 16 electrons. 16 electrons will cancel, and I'm left with 3iO3 minus, 24I minus, 18H plus, to 9I3 minus, and 9H2O. Lastly, for D, this is taking present in base. P solid, add PO4 3 minus, will produce in base H PO3 2 minus aqueous. Let's break this up into two half reactions. Phosphorus balance on each side, 3 oxygens on the right, so 3H2O on the left, 6 hydrogen on the left, so 5 hydrogen on the right. This would be 3 electrons on the right to balance the charge. Phosphorus is balanced on each side. I need an H2O on the right to balance the oxygen. That will leave me with 3 hydrogen on the right, so 3H plus on the left. Let's balance the charge here. We're neutral, -2, so add 2 electrons on the left-hand side, times 3 times 2. So 6H2O, P2P solid to 2HPO3 2 minus, and 10H plus, and 6 electrons, times 3 for the next one, 6 electrons, add 9H plus, 3PO4 3 minus, 3HPO3 2 minus, 3H2O. 6 electrons will cancel. 3H2O will leave me with 3 on the left. 9H plus would leave me with just 1H plus. Let's put this all together here. 2P solid, add 3PO4 3 minus, add 3H2O to 5HPO3 2 minus, and 1H plus. Switch this to basic. H plus will cancel. H2 will leave me with 2 on the left. And our final equation is this equation here that is balanced in basic conditions.